Okay, hey, I want you to take a look at page 54 if you would. If you recall, the title of this section is Finding Limits Graphically and Numerically. Graphically just refers to the fact that you're going to be able to look at a graph and be able to determine a limit. And numerically means you're going to plot some, not plot, but you're going to plug in some points and actually evaluate and calculate some function values and determine whether you believe, based on that evidence, there's a limit happening at C as well. So,
is this how we determine the limits with the sine and cosine graphs?
well, we haven't done. You mean something we did yesterday?
No, it was like at the beginning here with sine and cosine graphs, or I guess we just identify the domain and range where to go, where these scores to go.
Yeah, no, domain and range is different than limit. We'll talk about this. This is, you recall, were you here when we did this?
No, I wasn't here.
Okay, okay. All right, well this will be, I think this will be clear to you. All right, we're gonna take this, we're gonna go in this order here, graphically and then numerically. So on page 54, I'd like to work through the odds 11 through 19, and I will sketch a rough version of the graphs that they have.
Yeah, I saw your mom and dad.
Oh, here. Okay, that's a line, right?
I need to sharpen my pencils.
Okay, so does that limit exist? The limit of the function, remember a couple things to review about limits. When we talk about limits, we're talking about y values, right? Y values, all right? And the y values that we're interested in are the y values that the function produces as we get close to 3. So remember what this notation means here. This means x approaches 3 or technically gets infinitely close to 3, all right? Never actually gets there, though. We don't want x to actually be at 3, okay? We're only interested in x getting infinitely close to 3. What would you say there? As x is approaching 3, from either side, remember that because x lives on a number line, x-axis here, we can approach from either side. And technically, when you talk about x approaching 3, we're talking about approaching from either side. So as x is approaching 3, what is the function? Yeah, it's converging. It's converging to 1 here. Yeah, that's right. Good. So yeah, this is equal to 1. Okay. Now, what's true about the function at 3 as well? Remember, this is a different topic. Remember that there were two things that we emphasized a couple days ago. One is that if the limit exists, it's a y value. Okay, it's a y value. The second thing that we emphasized was that the limit of a function as x approaches c has nothing whatsoever to do definitionally with the function value at c. Nothing. Okay? But I can still ask the question, what is this function value at 3? What is it?
1.
Yeah, it is 1. Okay? So they do happen to agree here. And then we said something about that. When they agree, what did we say about the function? It's continuous. Good. Yeah, it's continuous at 3. Good. Yeah, so f is, we say, is continuous. Okay, hey, quick note. Tomorrow we'll go over your quiz, okay? The B's going to take it today, right? Success time. We'll go over tomorrow. Yeah, they're on RenWeb. You can look at the your scores there, but
Yeah, can you just drop them?
Oh, I thought you said there is a quiz tomorrow.
no. Sorry, we'll go over the quiz tomorrow. Because John, you had asked me about it.
Yeah.
I think B's the last one. I think you're the last one.
Yeah.
All right, 13.
I'm gonna name my kid in a
You
movie.
had a higher grade than me?
This is a piece function, a piecewise function.
Can you guys go to that Kids Bop concert at the Pavilion later? I will not go to that.
Is it actually,
If I can go from LA,
No.
I'm going to.
Yeah, I got tickets.
Why?
Because it's kids bar. I heard the list.
I would only go to get t-shirts ironically and then leave. You think there's still wolf t-shirts?
so you guys kids that are performing?
They still have tank tops.
Probably not even have to go. I just bought tickets.
Okay, what would you say here?
$10. It's kids pop, no
Shh,
kids
hey,
pop.
hey. Okay, kids go to kids club. All right, what would you say here?
2.
The limit of the function as x approaches 2 is 2. Okay, that's correct. Why?
Because it just works that way.
Well, it's true because as x is getting infinitely close to 2, the function values are converging and getting infinitely close to this value here, which is 2. Okay? So the limit is 2. Good.
Can I ask why you did not fill it in, and it's just a, because in the previous one you filled it in.
Right, this function's different. This function's a piecewise function, right? In fact, let's
What it, I've actually got to look this one.
I think you guys did. Didn't you do piecewise in algebra 2? You ever see those?
No.
Okay.
I don't remember anything.
A piecewise function is simply a function that's defined differently over different intervals. And so this particular function is the line 4 minus x. It's defined that way everywhere except at 2. Okay? So it's the line that's defined everywhere 4 minus x except at 2. For whatever reason, and this is just for really illustration purposes, at x equals 2, the function's equal to 0. Okay? So the limit here of the function as x approaches 2 is in fact 2. As we get infinitely close to 2, the function values, the y values draw infinitely close to this value here too, this y value 2. But, as you guys kind of have noticed here, f of 2 is what?
0.
It's 0, right, by definition there. So what can you say about the continuity at 2? Yeah, it's not continuous at 2, right, yeah. F
Uncontinuous.
is not continuous. Okay, good. All right, any questions on that, guys? Okay, look at 15, look at 17. All right, how about this guy? The limit as x approaches 5,
That's crazy.
the absolute value of x minus 5 over x minus 5. Okay? But what does this guy look like?
Of V.
Well, x minus 5 divided by x minus 5 is what?
1.
It's 1 as long, the absolute value of x minus 5 though has to be positive. And if it's positive, these bars fall off and then you just get x minus 5 divided by x minus 5. So it's 1 as long as x is greater than 5. But if x is less than 5,
Then no.
Right. so here, let me put a little note here. This is equal to itself if x is greater than 5, right? But it's equal to the opposite of x minus 5 if x is less than 5. And that's just the definition of absolute value, right? The absolute value of x, or the x I should say maybe, comes out as its opposite if x is less than 0. So if x minus 5 is less, if x minus 5 is negative, in other words, if x is less than 5, then this will come out as its opposite. So if x is bigger than 5, the 2 just cancel and you're left with 1. At 5, it's undefined, right? Because you end up with 0 divided by 0, which is undefined. But if x is less than 5, and this guy comes out this way, then the x minus 5s cancel and you're left with a negative 1.
What book is this from?
What's happening?
Okay.
This?
Yeah.
All right, so what would you say there about the limit?
Oh, that's Larson. Our book next year is that.
Oh.
It printed off.
As x's are converging to 5, in other words, as they're getting infinitely close to 5, what are the function values doing?
They're getting apart.
Well, okay, good. On one side, from the right-hand side, they're just living at 1, okay? So, and I think one of you mentioned, I think it was in here, the idea of a right-hand limit, and there is such a thing. We'll talk about that next year. We won't get into that now. So the right-hand limit here, okay, is 1, but the left-hand limit, as I approach 5 from the left, it's -1, okay? If they don't agree, then we say that the limit does not exist, right? The function has to converge to a single value. So it doesn't here, so D and E does not exist. Okay. And notice as well, f of 5 doesn't exist either.
Is it just because at f5 is 0? Is that why it doesn't exist?
It's because, okay, good question. No, it's because it's 0 over 0. Well, it's because really, Nick, you can either, you're dividing by 0 and you can't divide by 0. So the value on the top really doesn't matter. Thanks.
So is that the sole reason why it doesn't exist?
Here, yes. Here, in this case, yes.
Rodney. It's hard to get this one No, I'm mom enough. Spy Kids 3D is also Spy Kids 3D, that's the best.
No, isn't it Spy Kids like 4D?
Like Spy Kids 4 was the one that.
Okay, guys, okay. Spy Kids stuff, okay, come on, let it go. All right.
Spy Kids cartoon, like
Okay, hey, do you recall the tan graph? What values does tan not like?
The ones where it's 0.
Where the bottom, yeah, where cosine 0, odd half pies.
Yeah.
Tan does not like odd half pies. Okay, so we've got asymptotes there, right? All right, it goes like this. Yes, what would you say here? Yeah, as we approach pi over 2 from either side, it blows up. We saw an example, you weren't here for this case, but we did a little example of that scenario, right? As you approach, in this case, as we approach C, as we approach pi over 2, all right, from one side it goes down to negative infinity, coming in from the left, it blows up to positive infinity. Yeah, so again, D and E here. All right, one more of these graph situations.
Oh yeah, that one's
Oops. All right, now that's kind of a weird situation. 1 over x, cosine of 1 over x. Let's think about this. It'll be helpful here.
I don't think we want
It'll be helpful here if you think about what happens when you divide by these x values. It'll be helpful to cut the x-axis up into integers over pi. So I'm gonna go 1 over pi, 2 over pi, 3 over pi, like that. He gives you a picture of this graph, but I want to try to explain it to you a little bit. Okay, shh, Dave. All right, what happens at 2 over pi and negative 2 over pi? Let's think about this. Hey, I want you to picture again angles, these as being angle values as well ultimately here. All right, 1 over these guys. So, at least in my mind, I still think about going around in a circle, you know, in terms of angles. So what happens at 2 over pi and negative 2 over pi if I plug those in?
Well, cosine of pi is -1.
Well, first of all, what happens just with the argument, 1 over? Let's just concentrate, John, right there, 2 over pi. When you plug in 2 over pi for x, do you get pi over 2 and cosine of pi over 2?
Oh, okay, 0.
is 0, good, all right, so we get a 0 here, good.
Oh, so that's why you're doing it though.
Yeah, it's gonna, it just makes, I think it's gonna make more sense, the graph will make more sense.
It automatically flips it.
Right. Excuse me, guys. All right, same thing here, negative 2 over pi is gonna give you
Exactly.
negative pi over 2, so 0 down there, right? Okay. Well, what happens as you go out this way and this way?
It goes up.
3 over pi, 4 over pi, 5, we'll stay over here. 5 over pi, 6 over pi. What are we getting?
You're getting like a little minus.
Pi over 3, pi over 4, pi over 5, pi over 6. What's happening there? They're getting smaller, very good. And so the cosine values, that first quadrant, they're positive. The cosine values are getting close to what then? Well, the angle values are getting close to 0. What about the cosine?
1.
1, good, all right? So in both directions here, this is coming in from the positive side. As those values go out, the angles are going down. If you think of that whole thing as an angle, so the cosine values are getting close to 1. Same thing over here. They're just coming up this way, getting
How are they
close to
getting
1.
closer to 1?
Yeah.
Because as your angle is getting closer to 0, don't you get it?
Cosine's getting closer to 1 then, right? 'Cause cosine of 0 is 1. So you're coming in, John, like this. Your angles are coming in like this from this as they go out this way, all right? And then as they go out this way, the angle values are getting like small in the positive sense. So you could think of this as having a horizontal asymptote. All right, what happens at negative 1 over pi?
Beats beauty.
Well, let's think about it, okay?
Peter's born. That's negative pi, cosine of negative pi.
Negative 1, good. All right, what about 1 over pi?
Well, then you get cosine of pi, so the 1, which is just 1. Or negative 1.
Negative 1, right? So you're going to see symmetry here because that's the way cosine is.
I love symmetry.
Now what happens, guys? What happens as we start going in this way?
It starts doing that accordion thing, which is.
Well, why? Why does it do that?
I don't know why.
Let's think about let's think in terms of like tenths and hundredths and things like that. So if we did a tenth of this unit here, right? A tenth of. Well, let's do positive because it might be easier to think in terms of positive. If I did a tenth over pi, what would happen there? Tenth over pi.
You pi over 10.
Pi over 10, right? So pi over, not pi over 10, John. A tenth over pi would be like 1 over 10 pi. It'd be
yeah.
pi over a tenth. Sorry, because I got caught. So 10 pi, right? So what's happening, what is happening is we're going this way. We're in terms of angles, we're like doing like this. Yeah, and so now all of a sudden you're creating all of the cosine values infinitely as you approach 0. So you're taking the infinitely long wave and you're literally smashing it into this area right here. So what happens is, and that's a nice little picture there. What's happening is it's going like this forever, right? Same thing over here.
That's
Okay.
actually pretty.
Now, if you, I really needed to go all the way up to 1.
Kind of looks like the McDonald's logo.
Yeah.
I don't get it.
I'm loving it.
I watched that movie about the guy who created McDonald's, or not really created, but he like,
The one with
what's his name? Yeah.
Billy Crystal.
Hey, listen. Anyway, okay.
And he kind of just like,
Croc.
yeah, he kind of like screwed over the original owners too.
Yeah,
That's
that's
because
what
It seems like that's always part of every business
the
story.
original owners really wanted to keep it within
Yeah,
the
like-
localized area, and they wanted to keep control over the different
Like the tech
areas. But the other guy wanted to expand, and then he started wanting to like use, I think it was like the powdered milkshakes and stuff like that instead of the regular milkshakes.
That's
And
gross.
hate that.
So Croc's the one that messed it all up.
Yeah,
The
Crocs-
guy that made it big is he's
Oh,
got.
he didn't mess, or he didn't. I guess he expanded it and made it loaded, but
But the quality of the food was worse or something?
Yeah, pretty much.
Because
Because it was two brothers that originally made it. Two brothers named something McDonald, and then he kind of he partnered with them, and then what he ended up doing was creating a separate business that controlled the land at which McDonald's was on.
Pretty cool.
So I think he ended up somehow like getting around their contract, and then like left them with some money, but not a lot.
With Mr. Roach, have you seen the movie where that guy tries to live an entire month off of just like?
Yeah, I've heard of it.
supersized
I
food?
haven't seen it, but I've heard of
It's
it.
so gross.
Yeah.
What did you try to live off of?
It's just McDonald's food. It's
He-
called
he-
Oh, it's
supersized-
super fast.
Yeah, it's like called
Sup-
supersized.
Supersize me, yeah.
Yeah, it's like
Yeah.
at the very end, he gains like 100
He
pounds.
he gains a ton of
And
weight.
he's like,
And he
All right.
can't eat like any food that's not McNuggets, and he's like,
All right. Okay, didn't want to lose total control. Okay, Bennett,
he loses
wait.
comprehension of the English language because he's been poisoned by the Big Macs. So don't eat at McDonald's. Oh, if you do go to McDonald's though, get the McBang. So what the McBang
All right, Bennett. Okay, enough. Okay, we're good. All right, just, hey,
Sandwich.
if you look at the picture in the book, you'll see you'll see an attempt to graph this from some kind of grapher, and you'll see how it's all dense and dark in there, okay? Because these lines just get infinitely dense in here, okay?
did Larson hand draw these graphs?
No, he probably has some kind of grapher program that does it.
Yeah, I was gonna say.
Okay, hey, so listen, that's just a discussion about the graph. What about the limit? As x approaches 0, what does the cosine of 1 over x approach a particular value? No, it doesn't. It just bounces back and forth between 1 and -1 forever.
One and eventually hit.
I thought they
No,
were-
in fact, that's the whole point of this, John. You never get to 0, and it's undefined at 0, so you couldn't even conceive of it anyway. So these lines are getting infinitely dense like this forever and ever and ever and ever and ever.
The book doesn't show that very well. Takes a look
Well,
like this, it's still gonna go.
No, it's just getting denser and denser and going up and down forever and ever. Yeah, so D and E.
Today.
Wait, what? Hey, aren't you like Minecraft champion?
Okay, all right, that's a graphical approach, looking at graphs to determine limits, all right? Let's do now a couple examples of a numeric approach. So I want to go back to, let's see, take a look at, number 7 and number 9. All right, these are the last two we'll do, and I'll give you an assignment, you can work on it. You should be able to finish this before you leave. 7. All right, he wants you to find the limit. Now, we're not going to find it analytically. We're going to find it numerically. We're going to gather anecdotal evidence that will draw a not an inference from, but not deductive, so an inductive, I guess, result. We're gonna look at evidence, and we're gonna say it suggests that the limit is this, or it doesn't exist. Okay, so take a look at this guy. The limit as x approaches 3, and I'm gonna write the expression a little bit nicer looking than what you see in the book. This is a complex fraction. You saw these in algebra 2. Okay. So we're not, like I said, we're not looking at a graph here. What we're going to do is we're going to fill in a table.
I wonder what's for dinner. Cinnamon salt.
What's at the pharmacy today? Let's go inside.
You're probably bad traffic on research and
Guys, I'm gonna need some calculator help here, okay?
What do you need?
Anybody?
Calculus is all about calculators.
Okay, yeah, it's rare that we actually do this kind of thing, but, hey, what you're gonna do, listen, guys, let's do this in a coordinated way, so we don't, reproduce each other's work here. Bennett, I want you to plug this one in. Hey, are you guys okay? Do you understand how to write this in the? You have to put that in parentheses. You're gonna put that, if you write it just the way it says here, that'll have to go in parentheses, and then this whole thing on top will have to go in parentheses as well.
Oh my gosh.
Oh my gosh.
All right, the X values are there, he wants you to punch those out and find the corresponding Y values. Now notice here, 2.9, 2.99, 2.999, that's coming in from the left,
2.99.
right? That's getting closer to 3 from the left-hand side. 2.9, 2.99, 2.999, you could keep going like that, right? So he's coming in from the left. But in order for there to be a limit, you have to be able to come in from both directions and have the function values converge to a single value. So then he's coming in from the right, 3.1, 3.01, 3.001. He's getting closer and closer from the right that way. So I need 6 people here. All right.
I'm doing,
Which one are you doing? Okay, who's gonna do this? 2.99? 2.99? Okay, good, thanks. All right, 2.999, Matt, all right.
I'll do that one.
Okay, this one, John?
Yeah.
All right, 3.01, Diener,
Sure.
all right. Nick, do you have one? Or no, you have one,
I thought-
Antonio, you have one?
Yeah, I gave it to Greg.
Oh, okay.
I thought everything was, do I need to get one?
Yeah, get one out. You have one? Okay, oh, forget it, Nick. All right, do 3.1. Yeah.
Okay, and plugging it out, do we just plug that in?
You're gonna plug those values in for X up here.
It looks like a cosine. Looks like a tan graph. Cosine.
Well, you don't have to graph it.
No,
We're
don't
looking for,
Find the value.
yeah, we're looking for
Oh, I thought
the
I could
values.
get her the game. So I'm doing 3.01. So, let me get this straight. By 3.01.
I got a value, but I don't think it's right. I think I might have done something.
Well, all of these
What?
actual solutions are in the back, odds and evens.
Let me double check.
I got
Who did this?
Yeah.
This one, Matt? Okay.
Mr. Fetch,
So
I
negative-
got,
Negative, hang on one second, wait. Negative 0.6025?
Oh, 06. Okay. 0625.
Alright.
and then the one to the right, so for 0.301. I got negative 0.06248.
Okay, good, so it looks like it's getting a little close to his, yeah.
Mr. Bud.
Yeah.
Mine's negative 0.0626.
Same thing.
Good, where are you, right here?
Yep.
Okay, negative,
Negative 0.0626.
0.66. Alright, very good.
I got,
Dean, stop it.
Is this you, buddy?
yeah, negative 0.0641025641.
Hang on, negative 0.0641?
41. Yeah.
Okay, that's cool.
I'm 3.01, and I got negative 0.062344.
That's good, that's good. Alright, how about 3.1?
I'm working that one.
Okay.
I got the wrong
I did.
Yeah, shit.
Alright, John.
Yeah, shit. Okay.
Antonio, did you get it, Antonio?
I think so.
John?
Greg plugged it out and he got negative 0.0609. That rounds to 10.
Okay. That's good. Okay, so what would you conclude just based on that evidence here?
Lower.
It goes to
Alright.
.06, negative .0625.
Yeah, it looks like it's converging there. Now, you can't really tell if that's the actual value that it's converging at, but based on this evidence, yeah, it's close to that.
I plugged in one with a bunch of zeros.
Yeah.
And you get like negative .06249999.
Okay, good, good. So, yeah, it looks as though, and, you know, we don't need to be exact with this answer here because it's just based on this anecdotal evidence, but it looks like it's heading to this guy, negative .0625. Okay, good, good work. All right, let's do one more of those. Yeah.
Why do we have to check like 3.1? Can't we just check the ones that they give us?
Yeah, that's a great question. It's not that you can't, it's that he wants you to see
The convergence.
the steady convergence to a single value. So there's sort of a loss of that perspective if you just do two values. Because if you think about it, John, this is relatively close, but you can get infinitely closer.
Yeah,
So he's just saying, here, check these three, and can you see a convergence? You know. Yeah, that's a good question. All right, look at 9. Limit as x goes to 0 of sine x over x. All right, let me get a table out again. Okay, we're approaching 0, so he's got us coming in from the left, negative 0.1, negative 0.01. He just keeps going by a 10 times, I guess, farther in. Negative 0.001. Coming in from the right, same thing, 0.1, 0.01. Okay, hey, same thing here, Ben. You're on this. This one, hey, being rads here, this one's a lot easier to punch in. Being rads, even though technically it really wouldn't matter here, but being rads here. Okay.
I got .017.
Okay, for that one?
Yeah.
All right, just, hey, take the same position one you had last time, okay?
.01. Got it. So I got 4.
You say you got .017 for all.
Radians. Yeah, confirmed.
37.
Did you do this one, buddy?
Yeah, I need all. Well, I did like 3 and they're all .017, so I'm just assuming they're all.
No, it shouldn't be that. It shouldn't be that. Try it again. Hey, be in rads though, would you? Make sure you're in rads.
Can you
Oh,
assume
I got
straight
mine.
lines?
Pardon?
Can you assume straight lines?
Can you assume what?
Straight lines? Straight line?
Can I assume straight lines? What does that
Oh,
mean?
no, it's just
Trying to
geometry, just a geometry.
In geometry, yeah, that's one thing you
No,
can
I got
assume.
Yes, I've been telling you that. I don't know why you keep
.99.
0.99?
Did I assume a straight line?
Okay.
I did.
Third one, Matt, go ahead.
I got .99, but I had more times.
You're like 4 or something like that? 4 or 5? 6, okay.
36.
I have 6 9s.
How about this one?
I have 4 9s.
That one's mine, I haven't done it yet.
Okay.
I have .01 and I got 4 9s, 8 3.
You're wrong, man.
So 0.1.
You got 4 9s?
Yeah, the negative doesn't affect it.
And then 8.
Yeah, good call. It won't. And which? Why is that? Well, because remember, sine is odd. The negative sign comes out, and the negative then they will cancel. Yeah, good.
Oh yeah, okay. Really?
Oh, that's funny. So if it was cosine, that point value would be. I could eat it and then leave one extra.
Oh, Mr. Boats. Yeah, I got .999.
This one here?
Yeah.
Okay.
Let's see if we're right.
How many 9s, Greg?
Correct, how many nines?
Oh, there was 4 and then it got to an 8.
This way.
All right, we'll run through 5, yeah. How about these?
For 0.1, I got, 0.9983.
Good. Okay, how about this guy?
Yes.
0.001.
That should be the same.
It'd be point, I have right here, point, 69, 0.69s and an 8.
Okay, what does it appear to be converging to?
1.
1, yeah, good. And in fact, it does converge to 1. We'll prove it next year in calculus.
Uh-oh, that's right.
Is
This
this
is here.
Is this like a famous graph?
Yeah, that's a special limit in calculus. That's a special limit, yeah.
Can I go to the
Can you go to the restroom? Yeah.
Yeah, thanks.
All right, here's your homework, guys. Get this done before you go.
Homework. Oh, I haven't even
I'm a little.
I'll write it right here.
Homework. Hey, Kate, I noticed that you're singing the multi table. You're drinking for the straws.
Okay, hey, you should, honestly, this went by very quick for the other class, so work together on it. We'll grade it tomorrow.
Starting with number 4.
But yeah, I had you do 2 numeric ones, 4 and 10. The other ones are the graphing ones. And then those are true, 42, 43, 45, 46 are true and false.
Oh.
Well, that's a lot.
Okay.